Look around you right now. The air between your face and this screen. Feel how empty it looks. It's not. Nothing has never existed. Not once. Not ever. Not a single cubic millimeter of true emptiness a euro. Anywhere in the universe, in 14 billion years. In the next 35 minutes, 3 things you took for granted are going to stop making sense. The emptiness in your room, the Big Bang, and your own existence. All 3 are the same phenomenon. Last time, we proved that the energy in your phone charger doesn't flow through the copper a euro. It flies through the empty air around the wire. Tonight, I'm going to tell you what that empty air actually is. And one man, a euro, Richard Feynman, 1964, Caltech a euro, refused to teach it any other way. Picture the scene. 1964. A lecture hall at Caltech. 46-year-old Richard Feynman walks up to the blackboard to teach quantum mechanics to a room full of undergraduates. And he opens with a confession. Paraphrased faithfully from the lectures on physics. Volume 3, a euro. A book you can still buy on Amazon for $20 today. A euro, he says in effect. The way most textbooks teach you about empty space is inadequate. They say a euro, take everything out of a box. All the air, all the light, all the heat, every single atom. Now you have nothing. That picture is simple. It's memorable. It's wrong. The vacuum is not empty. It is seething. Virtual particles are popping in and out of existence 100 trillion times per nanosecond. And I have to tell you this honestly, a euro, because most textbooks refuse to. The fact that the honest version is disturbing is not a reason to teach you a comfortable lie. 60 years later, most schools still skip this lecture. Tonight, we don't. But before we walk through that door with him, a euro, you should know who Feynman actually was. Because if I just say Nobel laureate, I've already lost you. Here's who he really was. During the Manhattan Project at Los Alamos, he cracked the safes of the other physicists. For fun. Not to steal secrets a euro. To prove the security was theater. He'd leave little notes inside. Guess who? He played the bongos. In jazz bars. In Rio Carnival bands. And in 1986, when the Space Shuttle Challenger exploded 73 seconds after liftoff, Feynman sat in a congressional hearing, live on television. He pulled a rubber O-ring from his briefcase, dropped it into a glass of ice water a euro, and said, in effect, that's why it blew up. One sentence. Case closed. The man was a mischief maker with the forehead of a god. And when he said, the vacuum is disturbing a euro, let's be disturbed together a euro, he wasn't warning you. He was inviting you. Tonight, we accept the invitation. And to do that, euro, we have to rewind 300 years. Because the empty box you grew up with, a euro, it has a name and a date. The story starts in 1687. Isaac Newton publishes the Principia Mathematica a euro, the greatest physics book ever written. And in it, Newton gives space a job. Sit still. Space, in Newton's picture, is absolute. A rigid, invisible scaffolding that stretches forever. Planets move inside it. Apples fall inside it. But space itself, it does nothing. It's just the stage. Think of it as a giant invisible box. Things bounce around inside. The box just sits there. It's a comforting picture. It made sense for 200 years. And it is a euro. We now know a euro. Catastrophically wrong. The first person to crack it was a bookbinder who couldn't do calculus. 1831. Michael Faraday, 40 years old. The son of a blacksmith. An apprentice bookbinder who taught himself physics from the very books he was supposed to be gluing back together. And now he's in the basement of the Royal Institution in London, doing the simplest experiment you can imagine. Magnet, piece of paper, iron filings. He sprinkles the filings on the paper, moves the magnet underneath. The filings arrange themselves a euro, on their own euro, into curving lines. And Faraday realizes something every physicist for 2 centuries has missed. The space around the magnet is not empty. The magnet is doing something to space itself, creating tension, an invisible stretch, a jitter. He gives it a name. He calls it a euro, a field. Space isn't a box. Space is an infinite, invisible mattress of springs. Pluck one spring here, a euro. The jiggle travels everywhere. And that jiggle is light. It's radio waves. It's the heat you feel from the sun 8 minutes after it leaves. The establishment listens politely, files it under pictures in the head of a man who can't do calculus. 34 years later, a euro. 1865 a euro. James Clerk Maxwell writes down 4 equations that prove Faraday was right all along. The mattress is real. Fields are physical things. And light a euro. Is those fields vibrating? Classical physics reaches its most beautiful moment. And then it says something that sounds perfectly reasonable. It says, take all the energy out of the mattress. Stop every spring. 0 vibration. 0 jiggling. Perfect stillness. And you have a euro. Nothing. Makes sense, right? No energy to push things around? Nothing should move. Wrong. A quantum mattress, a euro. The kind of mattress the real universe is actually made of a euro, is physically incapable of lying flat. Hold that thought. Because in just a few minutes, we're going to take the single weirdest rule in all of physics, a euro, put it in Feynman's hand, a euro, and watch him prove that empty space can never, ever truly be still. The answer will take apart cosmology, the Big Bang, and the reason you exist, all at once. But first a euro, a stop in Copenhagen. 1927. A 25-year-old physicist with terrible hay fever is about to flee to an island with no flowers, and come back 2 weeks later with a rule that changes what empty means. Forever. June 1925. A 23-year-old German physicist named Werner Heisenberg is hiking through the countryside near Göttingen, sneezing his head off. His eyes are swollen shut. He can barely see the chalkboard in his own office. So his doctor does the only thing left. He puts him on a boat. Heisenberg sails to Helgoland, a tiny rocky island in the North Sea. No trees, no grass, No pollen, just cliffs and seagulls and wind, and a notebook. For 2 weeks, Heisenberg climbs the cliffs at sunrise, goes back to his room, and does math. Not the math Newton would recognize. Not the math Maxwell wrote down. A new math. One where you cannot, ever, under any circumstances, know two things about a particle at the same time. You can know where it is, or you can know how fast it's moving. But not both. Never both. On the night of June 7th, 1925, at 3 a.m, Heisenberg climbs to the top of the cliff, watches the sun come up over the North Sea, and realizes quietly, terrified that he has just broken classical physics. Here's the rule. In one sentence, no jargon, no equations. The universe refuses to commit. That's it. That's the whole thing. If you pin down exactly where something is, the universe responds by smearing out how fast it's moving. If you pin down how fast it's moving, the universe responds by smearing out where it is. Push on one the other blurs. Always. It's not a measurement problem. It's not your instrument being clumsy. It's not that we haven't invented a better microscope yet. It's baked into the fabric of reality. The universe, at its deepest level, refuses to hold still. And that one rule the universe refuses to commit is about to demolish everything Newton built. Because if nothing can ever truly hold still, then the empty box Newton drew in 1687, that box cannot exist. Anywhere. Ever. Let me show you why. Quick reset because what comes next is the part that breaks people. For the last 9 minutes, I've been building one claim. 1. The vacuum is not empty. And the reason it can't be empty is a rule a sick 23-year-old figured out on a rock in the North Sea. The universe refuses to commit. Now watch what happens when you apply that rule to nothing. Put your hand flat on whatever surface is near you right now. A desk, a steering wheel, your knee. Feel how still it is. It isn't. Every atom in that surface is vibrating. You know that from high school. Heat it up the atoms jiggle more. Cool it down they jiggle less. Freeze it to absolute zero minus 273.1 to 5 degrees Celsius and the atoms should stop completely. Except they don't. They can't. Because if an atom stopped completely, you'd know exactly where it was and exactly how fast it was moving zero. And the universe remember the rule refuses to commit. Stillness is forbidden. Not by law, by mathematics. The vacuum, the coldest empty box you could ever imagine, at minus 273 degrees in deep intergalactic space, 10 billion light years from the nearest star still jitters. We even have a name for the jitter. We call it 0-point energy. And it is the reason you exist. Which raises an obvious question. If empty space is jittering can we measure it? Can we put it on a scale? Turns out in 1948 a quiet Dutchman did exactly that. With 2 metal plates. In a basement. In the Netherlands. And what happened next is the first proof, on paper, that nothing weighs something. Before quantum mechanics, empty space is nothing. You cannot weigh it. You cannot measure it. You cannot put it on a scale of euro, because there is nothing there to scale. After 1948, wrong on all three counts. 1948. Philips Research Laboratory, Eindhoven, the Netherlands. A 40-year-old theorist named Hendrik Casimir is sitting at a desk, staring at Heisenberg's rule and asking a question nobody has thought to ask. If empty space is jittering a euro, if the vacuum is seething with zero-point energy every nanosecond, everywhere a euro, then what happens when you stick two metal plates in it? Very close together, face to face, no air between them, just vacuum. Casimir does the math, and what falls out of his equations is absurd. The plates should get pulled together, on their own, without a magnet, without electricity, without gravity, without any force that physics up to that point has ever named. Pulled together a euro, by nothing. He writes a 4-page paper. He publishes it. And for 49 years, almost no one cares. Because to actually measure the effect, you need two metal plates. Perfectly flat, perfectly parallel, less than 1,000th of a millimeter apart a euro, about 1/50th the width of a human hair, in a vacuum chamber, with a scale sensitive enough to weigh a single human eyelash from a kilometer away. For half a century, nobody could build it. Then, euro. 1997. Los Alamos National Laboratory, New Mexico. A physicist named Steve Lamoreaux finally does it. Torsion balance. Gold-coated plates. 6 months of calibration. And the plates a euro. Move. They are pulled together by a force of 1.3 microdynes per square centimeter. An amount so small, a grain of sand would crush it. And yet, a euro, it's there. It has been measured. Again. And again. And again. More than 24 times on 3 continents. Which means nothing is not nothing. Nothing is a substance. Nothing weighs something. Nothing has pressure. And we have now measured that pressure with a scale, in a basement, in a lab. The universe does not contain empty space. The universe contains almost empty space, and it pushes back. But the Casimir effect is not the first time nothing got caught red-handed. It's the second. The first a euro happened the year before with a light bulb. 1947. Columbia University, New York. A physicist named Willis Lamb is pointing a microwave beam at a glass tube full of hot hydrogen gas a euro. Basically, a light bulb with extra steps. He's trying to do something very boring. Measure precisely the energy level of an electron in a hydrogen atom. The simplest atom, the one every physics textbook uses on page 1. Quantum mechanics has already predicted exactly what number he should get. He gets a different number. Not a little different. Measurably different. Undeniably different. By an amount that, euro, according to every equation Schrödinger and Dirac ever wrote down a euro, should not exist. The error is 1 part in 100 million. And it is not an error. Take a breath. In, out. Feel your lungs expand. What just held your rib cage apart? Pressure. Air pressure. You know that. Now imagine a hydrogen atom sitting at the center of your left lung. One electron orbiting one proton. Perfect stillness. Perfect vacuum around it. Except there is no perfect vacuum. The electron is being jostled, constantly, by an invisible hail of virtual particles popping in and out of existence 100 trillion times per nanosecond. Just like Feynman told that classroom in 1964. The electron's orbit, a euro, the thing Lamb was measuring, a euro, gets nudged, ever so slightly, by the vacuum itself. And here is the part that should keep you up tonight. Modern physics can now predict that nudge, that tiny, vacuum-made shift in the electron's orbit, to 1 part in a billion a euro, and the related QED calculation to 12 decimal places. 12. We predict it. We measure it. The two numbers agree. It is the most accurately verified prediction in the history of any science, a euro, ever. Which means the jitter is real. The vacuum has a fingerprint. And that fingerprint is etched into every atom inside you right now. Ooh. You are being held together, euro. Right now, as you breathe, a euro, by a force made of nothing. The same force that pushes 2 gold plates together in a basement in New Mexico is the force keeping the atoms in your skin from flying apart. You are not solid. You are a standing wave in an invisible, jittering ocean that physics calls empty space. And the ocean was there long before you were. Which forces one last question. A question so heavy that when I first understood it, I had to sit down. If the ocean has always been there, a euro, then where did it come from? And what happens if, just once, somewhere, somehow, it ever stopped jittering? Whew. The answer is the Big Bang. And it is not what you were taught. Everything you were taught about the Big Bang is wrong. Not slightly wrong. Not oversimplified. For kids, wrong. Categorically, physically, mathematically wrong. The Big Bang was not an explosion. There was no bang. There was no fireball erupting into a pre-existing void. There was no before where space sat empty, waiting for the show to start. Because a euro, as we just spent 15 minutes proving a euro, empty space cannot sit still. Ever. Anywhere. For any length of time. So what actually happened? Take a pencil. Stand it on its sharpened tip. Let go. How long does it stay up? In the real world, a euro, a fraction of a second. Gravity wins. It falls. Now do the same experiment in a quantum world. A world where nothing is allowed to hold still. A world where even a motionless pencil is required, by law, to jitter. How long does the pencil stay balanced? 0 seconds. Not almost 0. Not a very short time. 0. Because the very act of being perfectly balanced is forbidden, a euro. The pencil is required to already be falling before you even let go. That pencil, a euro, is the universe. Before it existed. 1982. Tufts University, Massachusetts. A Ukrainian-American physicist named Alexander Vilenkin sits down at his desk and writes a 4-page paper with a title that sounds like a philosophy joke. Creation of universes from nothing. And in it, he does the math. The quantum pencil. The forbidden stillness. He writes down what the equations actually say, a euro. Not the cartoon version, the real version, a euro, and proves something that makes cosmologists lose sleep to this day. In Vilenkin's model, a euro, the simplest one, a euro, the universe did not begin with a bang. The universe tunneled into existence out of a vacuum state that was mathematically forbidden from remaining a vacuum state. The same rule, a euro. The universe refuses to commit a euro, applied to nothing itself. Nothing was unstable. Nothing collapsed. And the collapse is what we call time. The Big Bang was not a fire. It was a failure. The failure of nothing to stay nothing. You are not standing in the aftermath of an explosion. You are standing inside a 14 billion-year-old quantum mistake. And the mistake, a euro, is still happening. Right now, everywhere, in every cubic centimeter of the space around you. Here is the part almost nobody tells you. The Big Bang is not something that happened 14 billion years ago and then stopped. The Big Bang is happening right now. In the room you're in the cubic centimeter of air in front of your face. Because the vacuum, a euro, the same jittering, seething, forbidden to be still vacuum, a euro, is still pushing. Every second, everywhere. The universe is still expanding. Galaxies are still flying apart. And the thing that's pushing them, is the pressure of nothing. We even have a name for that pressure. We call it dark energy. And for 25 years, we thought it was a constant. A number, a fixed value. The universe's background hum. We were wrong. April 2024. Kitt Peak National Observatory, Arizona Desert. A telescope called DESI, a euro, the dark energy spectroscopic instrument, a euro, finishes mapping 6 million galaxies across 11 billion years of cosmic history. And what the data strongly suggests, a euro sends a shiver through every cosmologist on Earth. Dark energy is not constant. It's changing. The vacuum is weakening. The pressure of nothing is, very slightly, relaxing. Which means the Big Bang, a euro, the quantum failure that started it all, a euro, is still running. The pencil is still falling. 14 billion years in, and nothing has yet figured out how to sit still. Whew. Which brings us to you. Every atom in your body was forged in a star. You've heard that. It's true. But it isn't the whole story. Every atom in your body is also being held together, right now, by the pressure of a vacuum that is still collapsing. Your heartbeat is powered by electrons orbiting at energy levels nudged by virtual particles popping in and out of existence 100 trillion times per nanosecond. Your breath is filling your lungs against the push of nothing. You are not a witness to the Big Bang. You are a piece of it. Still underway. The universe failed to stay still. Nothing collapsed into something. And 14 billion years later, a small, warm, complicated version of that collapse is sitting somewhere, a euro, in a car, at a desk, in bed, a euro, listening to a voice explain why it exists. That version is you. And there is only one honest question left. If the universe is a failure of nothing to hold still a euro, what does that make us? And how are we supposed to live, knowing it? There are 3 answers. Only 3. And by the end of this video, a euro, you will have to pick one. Whew. So, here we are. 21 minutes in. 4 experiments behind us. A Dutch theorist, a sick German on a rock, a light bulb in New York, a telescope in Arizona. And the picture they paint together is this. You are a temporary pattern in an ocean of jitter that was never supposed to hold still. That fact doesn't change when you close this video. It doesn't change when you go to bed. It doesn't change on Monday morning when the alarm goes off and the coffee machine doesn't work. So the real question isn't whether it's true. It's how you live knowing it. There are 3 answers. I've watched people in my own life pick each one. And I'm going to name them a euro. Honestly, a euro. So you can pick yours. The first answer is awe. You wake up. You pour the coffee. And somewhere between the first sip and the second, you remember a euro. The steam curling out of the mug is made of molecules being held together by a pressure that does not exist. You are drinking a failed vacuum. And you laugh. Not because it's funny. Because it's absurd. Because 14 billion years of a universe refusing to sit still produced a morning in which you get to taste coffee. Feynman lived this way. You can hear it in the 1981 BBC interview. He's asked why physics matters. And he says, euro. In effect, a euro. The pleasure of finding things out is the whole point. The answer is not the reward. The looking is the reward. Awe is mindset 1. It costs you nothing. And it changes every ordinary thing. The second answer is acceptance. Because a euro, let's be honest, a euro, awe is exhausting. You cannot walk around gasping at coffee every morning. At some point, the cosmos has to become background. The commute still has traffic. The email still has to be answered. The kid still needs a sandwich. Acceptance says, the universe is a quantum accident. My life is a smaller quantum accident inside it. Neither one owes me meaning. And that is a euro. Strangely, a euro. The most freeing thing a physics lecture can tell you. If nothing was supposed to stay still, then nothing you do was supposed to be permanent either. The mortgage, the job title, the grudge you've been holding for 6 years, none of it is anchored to anything. Because nothing is anchored to anything. The anchoring is the illusion. Acceptance is mindset 2. It costs you your grip. And it gives you back your Tuesday. The third answer, a euro, is the hardest. The third answer is agency. If the universe failed to stay still, a euro, and that failure is what made you a euro, then you are the part of the universe that gets to decide what the failure turns into. Not in some mystical sense. In the most concrete sense physics allows. Your brain is a pattern of electrons being nudged by virtual particles, yes. But which nudges add up to a choice a euro. That part is yours. And that's where one more honest thing has to be said. About this video. About the voice you've been listening to. About what it is, a euro, and isn't. Okay. Pause. Before we go into the last 10 minutes a euro, there is something I owe you. The voice you're listening to was shaped by an AI. Not written by one. Shaped by one, which is a distinction worth making, clearly, on a channel whose entire premise is no comfortable lies. Here is what happened, honestly. An AI helped me draft the structure of this script a euro. The 9-section flow, the timestamps, the checklist of which experiments to include. Casimir, 1948. Lamoreaux, 1997. Lamb, 1947. Vilenkin, 1982. DESI, 2024. It cross-referenced those with Feynman's lectures, Volume 3, Chapter 1. It flagged jargon I might have slipped past. That's what it did. Here is what it didn't do. It didn't tell you the pencil on its tip metaphor. I chose that one because I once watched my daughter try to balance a pencil on its tip for 20 minutes. And she told me, furious, "Dad, the universe won't let me." It didn't tell you to drink your coffee slowly tomorrow. That came from me standing in my own kitchen, 4 a.m., staring at the steam. And it didn't tell you why any of this is supposed to matter. That part €, the part about how you live knowing it €, is mine to say, and yours to answer. Mindset, €3. Agency, €, is the choice to name the tools you used and take responsibility for the parts you chose. The AI is a tool, like Heisenberg's notebook, like Lamb's microwave beam, like Feynman's blackboard. The tool does not choose the question. You do. Which brings us finally to the last part of the story. The part the equations can't answer, €, but the physics demands we ask. If nothing was forbidden to sit still, and the failure of nothing is what made you a €, then what, exactly, is the universe trying to become? The answer, €, is you. And the last 9 minutes, €, are going to show you why. So, what is the universe trying to become? It's a question that sounds like it belongs in a philosophy seminar. It doesn't. It belongs in a physics lab. And it has an answer. A measured, peer-reviewed, replicated in 17 countries answer. The answer is, the universe is completed by being observed. Not metaphorically, physically, mechanically, with receipts. 1978. Princeton University, New Jersey. A 67-year-old physicist named John Wheeler, €, the man who coined the phrase black hole, €, is sitting in a conference room drawing on a napkin. He's been thinking for 30 years about the weirdest experiment in physics. The double slit. You shoot a single particle, €, one electron, one photon, it doesn't matter, €, at a wall with 2 narrow openings. Behind the wall, a detector. If you do not watch which slit the particle goes through, €, it goes through both. As a wave, and it builds up a ripple pattern on the detector. If you do watch €, it goes through one, like a marble, and the ripple pattern disappears. Every undergraduate physics student has done this experiment. It's been replicated with electrons, photons, atoms, even molecules of 60-atom buckyballs. The result is the same every time. Watching changes what is there. And then Wheeler asks the question that broke everyone's brain. What if €, he writes on the napkin €, you let the particle go through the slits first, and then decide whether to watch? The experiment was done. 1984, Maryland. Again in 2007, in Paris. Again in 2015, in Australia, with a single atom. The result? The particle's past behavior, €, whether it went through one slit or both €, is not fixed until measurement. Retroactively, the universe it turns out, doesn't just refuse to commit to where things are. It refuses to commit to where things were a euro until somebody looks. Which means this. Right now, you listening, you breathing, you deciding whether to keep this video on a euro. You are not watching the universe unfold. You are part of how it unfolds. The looking is the unfolding. The 14 billion-year-old failure of nothing to stay, still a euro, shit, does not finish without witnesses. And the witnesses a euro turned out to be you. So, if watching is the job a euro, what exactly are you supposed to do with that tomorrow morning? Here is the trade. If you watch this far a euro, 30 minutes is not free. You paid for this with the most expensive thing you own. So I'm not going to waste the last 4 minutes telling you to feel grateful or stay curious. That's a fortune cookie. Not a practice. 3 practices. 1 for each mindset. Each takes under 60 seconds. You can start tomorrow. Before coffee. First practice. 10 seconds. Once a day. Tomorrow morning a euro. The first time you pick up your phone, before you unlock it, a euro. Hold it. Feel the weight. And remember, the glass you're touching is 99.9999% empty space. The atoms in your thumb are not touching the atoms in the screen. They are being held apart by a pressure made of nothing that was forbidden from being still for 14 billion years. 10 seconds. Then unlock the phone. That's practice 1. It costs you 10 seconds. And it will, slowly, rewire what ordinary means. Second practice. Once a week. Sunday works. Pick one thing you've been gripping. A resentment. A regret. A story about yourself you've been telling for years. Write it on a piece of paper. 1 sentence. Then ask, is this anchored to anything the universe itself is anchored to? It isn't. Nothing is. The universe is a collapse in progress. Your grip is a smaller collapse inside it. Neither one was supposed to be permanent. Crumple the paper. Throw it out. Not because the feeling was wrong, because the grip was the illusion. Practice 2. It costs you 1 minute, once a week. And it gives you back rooms in your head you didn't know were being rented. Third practice. And this one is the hardest. Once a day, a euro. 1 sentence in a notebook. Or a notes app. Or the back of a receipt. The sentence is, today I noticed. That's it. Fill in the blank. The shape of a cloud. The exact pitch of your kid's laugh. How the air felt at 6 a.m. Anything. Because the universe a euro, according to Wheeler, according to Feynman, according to 14 billion years of jitter a euro, does not finish without a witness. And witnessing is not passive. It is the job the collapse required to complete itself. You skipped this practice? The universe didn't finish today. You did it? You were the thing the Big Bang was for. All costs you 10 seconds. Acceptance costs you a crumpled piece of paper. Agency costs you 1 sentence. That's the bill. For standing inside a 14 billion-year-old accident that accidentally produced the only thing in the known universe that knows it's an accident. Which leaves us with 1 last minute. And one last thing, Feynman said €, that most people have never heard. So, one last thing. We've walked through 5 centuries of physics tonight. Newton's empty box, Faraday's mattress of springs, Heisenberg on a rock in the North Sea, Casimir's 2 plates, Lamb's light bulb, Vilenkin's 4-page paper, DESI's 6 million galaxies, Wheeler's napkin, and a man in a Caltech lecture hall in 1964 who refused to teach you a comfortable lie. But there's one more Feynman moment that almost nobody quotes. And it's the one that closes every loop we just opened. 1955. Autumn. An address to the National Academy of Sciences. Feynman is 37 years old. He hasn't won the Nobel Prize yet, €. That's 9 years away. He stands in front of the most accomplished scientists in the country and gives a speech titled, "The Value of Science." And halfway through €, with no build-up, no fanfare, no equation on a board €, he says one sentence. Compressed to 8 words €. From a longer paragraph you can read on page 141 of the collected essays €. He says, 8 words. We are atoms that have learned to look at atoms. Whew. That's it. That's the whole thing. You are not a witness of the universe. You are a configuration of the universe that turned back after 14 billion years of jitter and noticed what the jitter was doing. The universe failed to stay still. The failure produced hydrogen. The hydrogen made stars. The stars made carbon. The carbon made you. And you, €, an arrangement of the exact same atoms that Casimir measured, that Lamb bent, that Vilenkin calculated, that Wheeler witnessed €, are now the part of the universe that gets to notice the universe. You are nothing, looking at itself, and finding out it was never nothing. Newton gave you the box. Faraday cracked the box. Heisenberg said the box could never be still. Casimir put a scale under the stillness. Lamb caught the stillness bending light. Vilenkin showed the stillness was the Big Bang itself. DESI caught the stillness still collapsing. Wheeler said the collapse needed a witness. And Feynman, quietly, in 1955, told us who the witness was. So before I let you go, €, there is one last thing worth saying. About what happens tomorrow morning. About the next video. And about the one question this whole series has been secretly trying to hand you. Tomorrow morning, €. The first time you pick up your phone, €. Hold it for 10 seconds before you unlock it. That's it. That's the whole assignment. 10 seconds of remembering that the glass under your thumb and the thumb on the glass and the space between them are all the same 14 billion-year-old failure of nothing to stay still. You are an atom that learned to look at atoms. Tomorrow morning, you get to do it on purpose. And here's the thing I haven't said out loud, €. Not in this video, not in the last 15. Every video on this channel has secretly been asking you one question. Not how does physics work? Not what is reality? The question is, what are you going to do with the fact that you noticed? You don't have to answer it tonight. You just have to know it was asked. Next video, €. We go somewhere stranger. If nothing is forbidden to sit still, and the failure of nothing is what made you